Currently this one's Grand Canyon University. Alright, so let's talk about the bell ringer. How do we go about finding the slope and y-intercept of these two lines that are on the board? What might be a good starting point, do you think? Starting with the y-intercept, right? So looking at that first one, what would our y-intercept be of that very first one? -7, and that's in an ordered pair as well. So how would that ordered pair be, Vince?
0, -7.
Good, so we started with this y-intercept right here. Came up with 0, -7. How do we go about figuring out the slope? Well, what is slope? Let's start there. What is slope? What's that? Something over something. What is that? Rise over run. Okay, so rise over run. So we need to figure out how much does it rise or could fall, right? And how much does it run left or right. So my suggestion would always be to start at the farthest left point that you know. So when I look at the line, what's the farthest left point? And then I'm going to rise from there and then run to the right. Anytime we run to the right, we know that's going to be a positive number. Now that would be my suggestion. It's not the only way, but that's my suggestion. So let's just say we do it that way. We start at the leftmost point, which happens to be the y-intercept. That's the one we know. How many would we need to rise to get to the next point that we know on that line? To get even with it. Not necessarily to it, but even with it. How many?
1.
We'd only rise 1.
And then go.
Do we know that that goes directly through that point, or is there 2 exact points on there that it gives us?
Which point?
There's 2 exact points, so I would use the 2 exact points. So with this second point right here that they've given us, how many do I need to rise up this way to get even to that point, Isabel? 7. And if we're rising, that means that it's a positive number. Now we need to figure out from once I'm to that point, so I rose 7, that took me to right there. How many do I need to run to the right to get onto that point, Cece? 6. And if we move to the right, that's a positive 6. So my slope would be rise, or I could say m equals 7 over 6. And then we would always look at that and say, can that be reduced? Can 7 over 6 be reduced? No, that's as simple as it gets. So my slope is actually 7/6. So that would be my suggestion. It's not the only way. We also learned about a formula where we could take the 2 ordered pairs that we know of those points and put them over each other to figure it out as well, called slope formula, right? And what was that slope formula that we had with the 2 ordered pairs where we had something over something? Do you remember that, Dee? What slope formula was? Who recalls what slope formula was? Yes, Cadence?
Wasn't it y2 minus y1 over x2 minus x1?
Perfect. y2 minus y1 over x2 minus x1. So we could also use that because that's equal to slope, which is essentially what we did right there. We just didn't use the ordered pairs, but we could put the 2 points that we know into that equation to figure out that formula, to figure out our slope. So that would be our way of just looking at graphs and being able to do that. So hopefully you were able to figure out slope and y-intercept on these. We're going to move on because this is a lot of what we're going to be doing today, is taking this and putting it into context in our notes today. So chapter 4 is all about writing equations in slope-intercept form. So we learned about slope-intercept form in chapter 3. What is slope-intercept form, Daniel? Oh, good use of your notes right there. Jump back in and remind yourself. Yeah, y equals mx plus b. So what we're talking about today is how to write the equations in y equals mx plus b, whether we're looking at a graph or we're given some information. So learning objective today, we want to learn how to write equations in slope-intercept form, and we want to learn how to use linear equations to solve real life problems. So you know what that means. We're going to have at least one word problem today. But we'll work through that together. So let's talk about words you need to know. One specific word, and it is linear model. Right? And this really deals with when we're talking about real-life problems, because linear models are used to solve real-life problems. And what a linear model is it's a linear function. We've been learning about functions, right? That model a real-life situation. So this real-life situation says, hey, all of these certain factors are going on, and so how can we use that information to predict future outcomes? Or how can we use that information to figure out how it went from point A to point B? So that's what a linear model is dealing with. And all linear models use the equation y equals mx plus b. So they all use the equation y equals mx plus b. So when we get to that real life problem, our whole goal is going to be, can we create an equation using y equals mx plus b and the information that they gave us. So that's really the only new term. Everything else is going to be stuff we learned from chapter 3. Slope, y-intercept, slope-intercept form, all of that type stuff that we learned previously. Now we're going to use it in a little different form than we have been. So let's about writing equations in slope-intercept form. So I really think this is basically kind of a 3-step process. Your first step, identify the slope. So whether we're looking at a graph like we just did on our bell ringer, or they just give us some information about slope. Because remember, slope is a rate of change. So we might have to do a little work to figure that out. We might use the slope formula. They might even just say, hey, the slope is this. But we need to identify that. Second thing is identify the y-intercept. Again, could be something given to us. May have to look at the graph. Could be something we have to figure out based on information that they gave us. And then third thing is plug those two pieces of information into y equals mx plus b. So the slope goes in for the m, the y-intercept goes in for the b, and the y and the x's stay y and x's. You're never going to be plugging anything in for y or x. Those are always going to stay the same. And then we simplify it if necessary, because some of the information might need to be simplified. It might make the x go away. It might make, there may be no need for the b based on where it is. All of those types of things we would simplify in that last step after we plugged it in. So that's really our 3-step process. We're going to learn how to use that with the different types of information that they give us. So let's take a look at this first one where they said slope equals -3, y-intercept equals 1/2. So first step, identify the slope. Well, they gave it to us. That's pretty easy, right? Second step, identify the y-intercept. Well, they gave it to us. That's pretty easy. Third step, Thomas, what is it? So we got to plug it in. So where does the slope go into this equation of y equals mx plus b? Goes in for m. Slope is always going to be your m, so we're going to plug that in for m. So y stays the same, equals -3. Does x change, Levi? Doesn't change, so x stays the same. And then where does the y-intercept go in, Ava? For the b? Yeah. So we're going to put it in as plus 1/2. Done. Pretty simple, right? Not a whole lot to it. We got to know the equation of slope-intercept form, y equals mx plus b, and then we just have to take the information they give us and we plug it into the appropriate spots. So here's our second one. Let's take a look at it. Slope equals 0, y-intercept equals -2. So when I look at this one, pretty straightforward. They gave me that information. So when I do that, I've got y equals, what's my slope, Jamie? Don't have a slope, but it's, what did they say? 0. And what does it go in for? Does it go in for the y? Did I put that down wrong? Where does slope go in that equation of y equals mx plus b? Goes in for m. So I'm going to end up with 0. Hold on. 0 times x, right? Because x doesn't disappear on its own. And then what's my y-intercept? -2. So I would have plus a -2, or there's another way of writing that. Now, can that be simplified? How so, Jamie? 0 makes x go away, so that goes away. Anything else that I could do to simplify it? What about that plus -2? Can that be written in a different way? Just be written as -2, right? So my final equation there is y equals -2. So you're not wrong if you wrote y equals 0x plus -2. That's a fine way to write it, but the simplest form where we need to get to is y equals -2. All right, so third one, you guys do it. Check in your group, see if you came up with the same answer. See if you got the same answer on that one. And then we'll check it here in a second together. We're looking for simplest form of it. All right, Brooke, what did you come up with for this third one? What was your final equation that you came up with?
Y equals 3x.
Y equals 3x. Do you agree with that, Destiny?
Yes.
Yeah? What happened to the y-intercept? We don't have anything behind the 3x. Where's it at? Simplified it, right? It would have been plus 0, which is the same as just y equals 3x. So good work right there. So those ones are really straightforward because they gave us the slope and y-intercept in the simplest form. Now sometimes they make it look a little more complicated. So these are back to our graphs that we're looking at. So again, we've got to figure out what is that slope and y-intercept. Now we did that first one in our bell ringer together, so you should have that information. Now you just simply need to take those two pieces of information and plug them into your formula, your slope intercept form. So you've got those two pieces of information from your bell ringer. So check that out, use those two pieces of information and plug it into your equation. And then we'll figure it out from there. Signs to simplify that to one. So what does that mean? There you go. There you go. All right, so Levi, what did you come up with for your equation on this first one?
Y equals 7 over 6x plus -7.
Y equals 7 6x. You said -7.
Mm-hmm.
Do we agree with that, Lane? Yeah? Well, if we did that stuff that we did in the bell ringer, we've got those two pieces of information and we can do that. What about this second one? You guys do that one real quick and we'll check that here in a minute. Check with your group. Make sure you came up with the same thing. If you didn't, work it together. Figure out where we went wrong. How'd you figure this out for yourself? Is that the farthest that one? Which way is that? You could start the right one. What do you need to think about? All right, let's talk about what'd you come up with for your slope on this one, Kieran? -1 over 1. Do we agree with that?
No.
Where's our 2 points? Remember, always go to the 2 exact points they gave you. Because sometimes it looks like it goes down one into the right one, but if you look real close to that graph, it doesn't quite hit that intersection of 1, 2. So that's not quite there. So what are the 2 points, D, that you see?
3 over 4.
3 over 4 is what you came up with? All right, so how did you get there? Well, you got something to add to that, Cece?
I think it's
negative 3 over 4? Why do you, I see you shaking your head yes, Isabel. Why do you guys say it's negative 3 over 4? Because you go down 3. So if we start at the farthest left point right here, and we have to go down, and down is always negative. Then we would move to the right, which is a positive number, and we would move 4 to the right. So slope, or m, equals negative 3 over 4. What's my y-intercept of this one? 3, right? So y-intercept is 3. So what's my final equation going to look like, Austin?
Y equals negative 3 over 4 x plus 3.
X plus 3. Do you agree with that, Daniel?
So I was just wondering if it matters if I got 3 over negative 4.
3 over negative 4 that means the same thing. As long as you only have one negative attached to it, you can do that. Because like Jamie started on the right point, which you can do. She went up 3 and left 4, so that would make the 4 negative. So you could start at either point. I always just, again, the way my brain works, I start at the farthest left because we read from left to right, and I go down 3 to the right 4. That's just the way my brain works. Either way will get you there, though. All right, so let's take a look. And always use the exact points they gave you. So if they give you highlighted points, use those. So how are you guys feeling? Give me a thumb sign with where you're at to this point. Hopefully feeling pretty good. Okay, excellent. So let's take a look at a couple of others. So they want us to write an equation of each line that passes through the given points. Negative 3, 5, comma, 0, comma, negative 1. So those are my 2 points that they gave me. All right, now I could go and graph these points and connect them to make a line. But rather than going through all that work, what's something we could use to figure out what the slope of this is based on these 2 points? Yes, EC? Yeah, the slope formula, the one we just talked about. Which word did you say it was, Cadence?
Y2 minus y1 over x2 minus x2.
Very good. Y2 minus y1 over x2 minus x1. That's going to give us our slope. All right, so we can figure out slope from there. So let's do that. Let's plug that in. So again, we learned that you can use either order pairs than 2 and either order pairs than 1. They just have to match up from top to bottom. So I'm going to say negative 3, m equals negative 3. Oops, sorry, that should not be negative 3. I almost made a mistake there. What number should that be if I'm using that ordered pair? Yeah, it should be the 5. Very good. So 5 minus negative 1. So don't forget, just because it's already a negative, we can't get rid of it. And that affects our equation. Over negative 3 minus 0. And then I can go from there. So what is negative 5, or excuse me, not negative 5, what is 5 minus negative 1, Lane?
4.
5 minus negative 1? What happens when we have double negatives? It's really a positive, right? So it's like a double, call it a double agent. So it becomes, so what's 5 plus 1? 6, very good, Jamie. And then what's negative 3 minus 0? Negative 3. So I end up with a slope of 6 over negative 3. Now, we always have to look, can that be reduced? What's it become? Negative 2. So my slope is negative 2. Now, what's the other piece of information I need to be able to write that equation? The x-intercept? Y-intercept. Now, y-intercepts always have what coordinate for x? 0. Do one of those points have a 0 for the coordinate x? So there's our y-intercept. So our y-intercept is this ordered pair right here. So I've got what I need to write my equation. So now I'm going to go in and write it. Y equals, slope is negative 2, x plus a negative 1 or minus 1. So y equals negative 2x minus 1. Slope was negative 2, y-intercept was negative 1, so y equals negative 2x minus 1. All right, let's take a look at a second one. Have you guys kind of walk me through this one. So this time points of 0, -5, and 8, -5. So on this one, Isabel, what do we need to use to figure out slope?
y1 minus y2 over x1 minus x2.
Yeah, technically the way they write is 2, the y2 minus y1, but either one, and it's really just 2 points from y over 2 points from x. So here we go. So what points do you want to use where?
5 minus -1 and -3 minus 0.
Right, we're on the second one.
-5 minus -5 and 8 minus 0.
-5 minus -5, and you said 8 minus 0. So use the second ones first, and the first one second. So that works. So when I go -5 minus -5, Levi, what's that become?
Would it be 8
Oh,
minus
8 minus 0, sorry. Yep, good catch. Now finish me out. What's -5 minus -5?
Oh, wait.
Double negative makes it a, yeah, makes it a positive, so I end up with 0 on the top, and then 8 minus 0 for the bottom is 8, but what is 0 over 8? It's 0. It's not undefined because the 0's on the top. Alright, so 0 over 8 is 0, so my slope is 0. Now what is my y-intercept for this line? Yeah, it's that first order pair they gave us of 0, -5, so that's my y-intercept. So what's my equation going to be, Brooke?
Y equals -5.
Y equals -5. What happened to my x?
0.
It was multiplied by 0, so it disappeared. Like Harry Houdini on that one, right? So y equals -5 would be. Because really what we had was y equals 0x minus 5. Well, that went away, so we can simplify to y equals -5. All right. One last one, you guys do it. Check it in your group. See if you come up with the same slope-intercept form of that equation. Now remember, if you start with this order here on top, you have to start with this order here on the bottom. Alright, so what did you come up with for your equation on this one, Kieran? Y equals -3/4 x plus 2, is that what I heard you say? Do you agree with that, Tanner? Yeah? Do you agree with that, Cece? What don't you agree with?
Well, I got just 3/4.
You got just 3/4. Anybody else come up with positive 3/4? We had a couple. So let's put it in slope formula and just see what that slope, whether it's positive or negative. So m equals y2 minus y1 over x2 minus x1. So I'm going to choose to use the -1 minus 2 over 4 minus 0. So -1 minus 2 is, what's that become, Vince? -3. 4 minus 0 is 4. So it's -3/4. So sometimes we may put it in one order on the top, which I was talking to someone about earlier, and then the other order on the bottom. It has to line up. So that point of -1,4 has to line up, and that point of 0,2 has to line up. All right, so from top to bottom. So make sure you got that. The 0 minus 4 is 0 minus 4. minus 0 is 4. 0 minus 4 is negative 4.
No.
If you have nothing, you take 4 away, that makes you really win the whole, so you get negative. Got it? Good? Alright. So let's take a look at some ones that look a little funkier. So this is linear function. So we've been working a little bit with this, right? And they say, hey, write a linear function of f with the values f of 0 equals 10 and f of 6 equals 34. Now, something we have to remember and we oftentimes forget is f of x equals y. Those are the same things. They're interchangeable, right? F of x equals y, right? F of or g of x equals y, or h of x, whatever function letter you're using, that's the same as y. They're interchangeable. Putting it as an f of x just simply means that it's a function, all right? Well, what did we learn? What is slope-intercept form? Y equals what? mx plus b. Well, if f of x equals y and y equals mx plus b, we can logically then say f of x equals mx plus b. That would be a normal thing to say because f of x equals y, y equals mx plus b, so f of x equals mx plus b. Now, using that first piece of information of f of x equals y, we can now go to that f of 0 equals 10. Well, 0 is which variable in f of x equals y? It's the x, correct. And the 10 would be the y. So there's your ordered pair. So the ordered pair is 0, 10. So now we're back to the ordered pairs, which looks a little bit more familiar. Now f of 6 equals 34, what would the ordered pair of that be? 6, 34. So that's all it's really saying on those, all right? Is hey, x is next to the f, y is on the other side of the equal sign. So using those two pieces of information, now we can go back to what we just worked on using slope formula, two ordered pairs, find our slope, find our y-intercept, and plug it into the equation. So you guys do that, right? And then we'll check it here in a minute together. So which one goes on top? Y is your x's? You what? Say 0, 1, 6. All right, so what did you come up with for your slope on this one, Jamie? Came up with 4. Do you agree with that, Levi?
I'm not just.
Not quite there? What do you think, Daniel? Yeah? What do you think, Vince? You say yes too, Thomas? I would agree. If you put those numbers in correctly, you would come up probably with, what, 24 over 6? And then you would be able to reduce down to 4. Or you might come up with negative 26 over negative 4, which would become, or over negative 6, excuse me, which would become positive 4. What's the y-intercept of this one, Tanner? 10. So the y-intercept is 10. So final equation for us is what then, Adriana? Y equals 4x plus 10. Very good. Right, so you've got another one on there. You guys try it out. Check it within your groups. See, make sure you're getting the same thing as each other. Help each other through it. So there's a second one on there for you. this is common, is you've got y2 minus y1, right? So you chose to make this y first. So you have this one minus this one. Well, what number is this? So you'd have minus negative 4. And that changes it, right? Yes, Steve.
I'm not sure how much of the y intercepts.
So remember, y-intercepts always have what coordinate for the x? All y-intercepts have the same coordinate for x, and what is that?
Oh, sorry, 0.
0, right? Do either the ordered pairs or have 0? So that would be your y-intercept.
Okay.
What did you get?
All right, Levi, what'd you come up with for your final equation on this one?
I got y equals 6x minus 4.
Y equals 6x minus 4. Do we agree with that? No? So where do we think we went wrong? We got 12 over 3, which would be good for the slope. What is 12 divided by 3? It's 4, right? So we just made a slight division error there. So y equals 4x minus 4. Do we agree with that?
Yeah.
Y equals 4x minus 4. So just make sure you take your time. Those small mistakes tend to get us. Your process was perfect, Levi. You had this slope formula incorrect way. So you just got to make sure you get those. All right, one last one there. Do it with your partners. All right, check your steps. Make sure you got it correct. How are you doing, Ava? All right. So Cadence, what did you come up with for your final equation on this one? Oops, almost went too far.
I got y equals 1/4 x.
Y equals 1/4 x plus 9. You don't sound so confident in yourself on that one. Not confident? How confident are you in that, Cece?
I think it's right, other than I think 1/4 needs to be negative.
The 4 needs to be negative. You think negative? What do you think, Daniel?
The 1/4 x plus 9.
You think so? So it seems like we got some debate about slope. What do you think, Dave?
Negative 1 over 4.
Negative 1. So let's take a look at it. So my ordered pairs are 0, 9, and 8, 7. So Cece, walk me through finding my slope. M equals, what'd you put on top first?
I put 9 minus 7 and 0 minus 8.
9 minus 7, 0 minus 8. So we'd end up with 9 minus 7 is 2, 0 minus 8 is negative 8. So can that be reduced
Yeah.
to what? 1/4, but one of those numbers was negative, so it's got to stay negative. So negative 1/4 x, you were really close. Right? A lot of us forget that negative, especially when we go to reduce, we forget to get that negative on there. So most of you saw at least had 1/4. We're getting to that spot. Just don't forget those negatives. Right? Don't forget those. Right, give me a thumb sign with where you're at on the linear functions. I know they look a little bit crazier, but really we just have ordered pairs there. And if you can decipher the ordered pair, you're in good shape. All right, so let's solve real life problems. Let's talk about this one. Everyone's favorites, I know. Everyone's favorite. So we've got that process we've been talking about. Read the problem, identify the key words, assign variables if needed. All right, all of that piece of information we've been talking about. So let's read it. Excluding hydropower, U.S. power plants used renewable energy sources to generate 105 million megawatt hours of electricity in 2007. by 2012, the amount of electricity generated had increased to 219 million megawatt hours. Write a linear model that represents the number of megawatt hours generated by non-hydropower renewable energy sources as a function of the number of years since 2007. And then use the model to predict the number of megawatt hours that will be generated in 2017. That's a mouthful. Alright, so let's really break it down to what it is. Right? So first thing I notice, alright, is linear model. We talked about that at the beginning of the class. What equation does linear model use? Y equals mx plus b. So we know we're trying to, oh geez, that's terrible. Alright? Y equals mx plus b is really where we're trying to get to. And this one's not much better. I drained out all my markers while I was gone. Alright, over the weekend. So y equals mx plus b, that's where we're trying to get. Alright? So we need to obviously find slope. So we've got to figure out some slope. Oh, there we go. It's like soothing to look at that. Slope, and then we've got to figure out a y-intercept. Now, I mentioned earlier that slope was not just rise over run, but what was that term I used about slope? It's a, you may remember, catch on to that, what I said earlier? We talked about it before, but I said it earlier today in class. What do you think, Lane? Let's finish this problem again after that. So what do we have to do? Remember we talked about, so we have a line, it's constantly going this way, going this way. It's constantly doing what? It's going up, it's changing and evolving, right? So slope is really a form of a rate of change, right? Rate of change, I said that earlier. So a lot of times we forget that slope actually means something. It's not just a number, but it actually means something. It means it's a rate of change that's happening. And it's usually a consistent rate of change, and we're talking about linear stuff, right? So now let's go in and let's just, keeping this stuff in mind, let's identify any key words that we think are going on. So what's the first key thing that you see, Daniel?
The 105 megawatts.
Yeah, 105 million megawatts. That's definitely important, all right? What else besides that, Thomas?
219 million megawatts.
219 million? What do you have there, Brooke?
I put in 77.
Yeah, this happened then. That's important. All right? When did the 219 million happen? 2012, right? So that's important. When those things take place, right? Anything besides that that's important? A prediction. We're going to eventually have to do that, right? Anything else, UCG, that you think might be important?
Number of years since 2007.
Number of years since 2007. That's really important. All right, that's really important, and we'll talk about in a minute why. So we know that when there was 105 million, all right, I'm just going to abbreviate that, in 2007. And then it went to 219 mil in 2012. Now, what happened from 2012 or 2007 to 2012? Did it stay the same? It what? It increased. It changed. Wait, changed. Something changed?
Slope.
That's our slope. So we got to use this piece of information to figure out our slope, because this is a rate of change. So when we have two pieces of information and they are not the same and there's a time happening and then it's changing, then we know that that's important. Now, with that, we also still have to find a y-intercept. Now, this key piece of information Dee pointed out, number of years since 2007. So 2007 is really our starting or ending point? Starting point. So really, this is our start. Well, anytime you start anything, do you start at 1 mile into a race? Where do you start? You start at the beginning, the zero, right? So this is really like a zero. Start is always like, hey, this is where I'm at, and I go from there. Start at the beginning at 0, and we build from there, right? Then the function of the number of years since 2007, that's a build, right? So that's going to be a next. So how many years do we have in between these two? 5 years, correct. Very good. So we've got a start of 0, and then for 5 years, we've got a rate of change happening. So off of this, we can actually create ordered pairs. Because, hey, here's our start, our beginning time, our x, all right? Because if we were looking at this on a graph, like this, right? This would represent years. This would represent that energy being used. Or excuse me, other way around. I wrote that the wrong way. This would represent energy used. And this would represent years. So this is our time. We're constantly getting farther and farther from the origin, right? And we're moving on. And then we're constantly increasing, because we said that was an increase, Thomas did, of energy. Right? So years to there. So off of this, knowing that the start is 2007, 105 mil, what might be an ordered pair we would create off of that, D? Well, what is our X and what is our Y? Years is our X, correct? And energy used is our Y. So what would the ordered pair here be? When you look at this, which one represents X, which one represents Y?
The 105 million represents Y and 77 represents X.
And then because 2007 is our beginning time, we said that it's the equivalent to what? Start, which is 0. What's that look like right there when you have 0 for the X coordinate? There's a Y-intercept in there, right? So now we've got a Y-intercept. What would the ordered pair for this one be? What do you think, Jamie, for this one right here? Good, so this would be 5, 219. So we've identified a y-intercept, that's a good thing, right? But have we figured out our slope? We haven't. Can we now though? We can, because we have a formula for that. So what would that look like, Thomas, if I put it into the formula?
You want me to do the whole form?
Yeah, give me the whole thing using those two ordered pairs.
Okay, I do 219.
219
minus 105.
minus 105.
Then I would do 5 minus 0.
5 minus 0. Good. So what does that come out to be?
114 over 5.
Over 5. Now, we could leave it like that, right? And that's completely fine, right? Since we're going to potentially plug some information in, the equivalency to 114 over 5, if you put it into your calculator in decimal form, would be 22.8. And since it's a function, and we're going to have to put a number in, because we've got a prediction, as Dee said, that we've got to do later, that would be what I do. But do I have enough information now to write a linear model? I do, don't I? Because linear models are in the form y equals mx plus b. So what is my linear model here going to look like? What do you think, Jamie?
Y equals 22.8x.
Plus 105, she said. Do you agree with that, Isabel Foley? I agree with that. So now we've got a linear model. Now, because we have a linear model, right, we can predict what's going to happen in the future. Right? Now, things could change, obviously. There are factors that affect the future. But based on current trends, all the way to 2012, we can predict what's going to happen in 2017. How? Put what? 17? Is that how many years it's been? 10. Very good. So we have to go how many years it was since 2007, which you said was 10. So to figure that out, I simply plug 10 in for x, as you said. So 22.8 times 10 plus 105. Well, this is a power of 10. So what's 22.8 times 10? 228 plus 105, which is 332?
333.
333. So we end up with 333, alright? And the last thing you gotta do, because it's a word problem, is we gotta answer it how they asked us. So you might say something along the lines of, in 2017, the, let's see, what is it? Renewable, non-hydro, super long tag, renewable energy source used will be 333, what was the tag for this one? Million megawatt hours. Million megawatt hours. So don't forget those tags that they gave you. Good. So there's only one word problem that I put on there just so we get some practice. Identify what are the two things that are going on. What's that rate of change? How do we create those order pair? Where's the start? Where is not? So you've got about 4 minutes if you want to jump into starting your assignment. Those first couple go pretty quick. They're just like our examples that we did. You've got a couple minutes to start on that. Thank you guys for your willingness to be the guinea pig class when it comes to the video. I certainly appreciate your help.